What's up everybody guys, welcome back to Myanmar tutorial. So what are we gonna make like this? So basically we have two topics. One is a depth estimation without Kinect. We can get the depth by web camera, but there's some limitation or how to use it. So I'm gonna show you how to do that. And also you can learn about the particle from the mesh. As you can see, the particle burst from the mesh. So I'm gonna show you how to do it. So it's really good for the interactive system, interactive experience. So are you excited? So let's get started. So before we get into this tutorial, so I want to say something. If your file doesn't work correctly, please double check your process carefully. If still doesn't work, consider checking out my Patreon to download sample files. Okay, that's it. So let's go. First of all, I'm gonna add the body tracking chop. So I already explained this body track chop for interactive experience with this video. So you can learn more about the body track chop. Some limitation, because the body track chop only work on the PC that has an NVIDIA GPU. So if you're using the Mac, it doesn't work. Sorry, but it is what it is, right? Okay, so now we want to get the depth. So to do that, we need to turn on the people tracking and also here body 3D. That's really cool. So basically, if you turn on the body 3D, you can get the position of the joint, the body's joint in a 3D space. So it has information of X, Y, Z. So the depth means the Z position in this chop, okay? So and I'm gonna change the field of view to the 90 because I'm gonna at the video device in. So my web camera has a 90 FOV, but I'm gonna use the movie filing because this is for the test, and I'm gonna trim because I have anything that I don't need. Maybe this one is correct. Yeah, this is a 90 degrees. So that's why I specified here 90 degrees. Okay, and I'm gonna have to switch top, and I'm gonna have the no top. So we can always switch the test or the real experience. And I'm gonna drag and drop to the top. So let's switch it. So you can see you already get the information, right? Cool. Okay, so let's move on. So I'm gonna have the trim, and you need to value is absolute. So now you only get one frame. And then I'm gonna have to no. Also, I'm gonna change the max bodies to 1 first of all. So now you can see the 1 bodies. So if you don't have this type of the video, you need to record your video for test. Okay. Next, I'm gonna add the base comp from here, and I'm gonna call it 3D position cleaned. So let's dive into it. And then first of all, I'm gonna delete, and then I'm gonna turn on the delete, and then I'm gonna write the asterisk b box asterisk, so I can delete this value. And then I'm gonna add the math. And I'm gonna change the value. So to here from range to 1000 to range to 0 to -1. And then I'm gonna only apply for TYZ. And then I'm gonna add another math. So and I'm gonna change the range to 0 to 1000 to 0 to 1. But this is only for TX. Okay, perfect. So I'm gonna add the select, and so I'm gonna specify the TZ. So if you see the TZ, it's very laggy. I don't know how to say it. Like it's very so we want to cut the this noise. So which means we should like stabilize the Z value. So that is what we gonna do that. So also I'm gonna add the base comp here, and then I'm gonna call it stabilize Z depth. So I'm gonna add the select chop, and then channel name is asterisk tell this, and then get to the position t asterisk, and then I'm gonna add the shuffle, and then method is sequence every nth channel, and then I'm gonna add the analyze, and then I'm gonna add the math, and then combine channel is length, and then I'm gonna add the filter, and then I'm gonna add the trim and absolute, and I'm gonna add the, another math from the math one, so math, and then combine chops is divide, and then I'm gonna connect from the device to math one, and I'm gonna change the order, so like this. I'm gonna organize a little bit, and then I'm gonna add the math here, and I'm gonna connect it, and then the combine chops is multiply. So let's see how we stabilize. So I'm gonna do select, and then I'm gonna specify tz. Yeah, you can see here is more like a smooth, but if before we add the filter, it's like have a noise. Okay, perfect. So I'm gonna delete it. So I'm gonna go up, and then I'm gonna add another filter, but this filter is for the adjust, so I don't use it right now. But if you have any preference to add the filter to smooth the movement, you can do that. So, and then you can click on the filter per sample. But now I don't use it. And the next, we're gonna visualize human from this value. So first, I'm gonna select, and I'm gonna specify the nose, and it's colon and asterisk, so we can get the information of the nose. Okay, and also I forgot to turn off the key point confidence, and I'm gonna no. Okay, so I'm gonna copy and paste the select. Second one is we want to get the shoulder and hips. There you go. And then I'm gonna add another select, and then we get the only position data, so which means like a T, so we don't have to use the rotation data. And then I'm gonna add the order, and I'm gonna change to here character pattern. So I think it's not a good solution, but I'm gonna write the order what that I want. So first is a left hip and T wide curd, and next one is asterisk left shoulder and T, and now is asterisk right shoulder T asterisk, and then last one is a right hip T asterisk. Left hip, left shoulder, right shoulder, right hip. Okay, perfect. And I'm gonna add the shuffle, and method is a sequence or sample every nth frame, and I'm gonna add the rename, so cos T XYZ, and then I'm gonna add the no, so I'm gonna call it this is for body. And then last one is the head. Okay, this is for the body, so I'm gonna do another things, so I'm gonna copy and paste it. So next one is the shoulder, and then elbow, and wrist, and then I'm gonna add the new select. So this is for right asterisk colon T, only use the position data. So I'm gonna copy and paste it, and then this one is for left. And then I'm gonna add the shuffle. This is also like a sequence or sample event frame. And I'm gonna rename it T XYZ. And then no. So this is for light arm. And I'm gonna copy and paste this one and then reconnect it. And this is the left arm. So I'm gonna copy paste this one to here. And then so we need to change it to here is hip first. Second one is knee. And the last one is ankle. And this is a right leg. This one is left leg. Okay, cool. So I'm gonna add the sphere, and the primitive type is a polygon, and the radius is 1, and y is 1.2 to make it, you know, like a human head shape. And I'm gonna change the anchor V to 0.75, and anchor W is 1. And then I'm gonna transform, and then so I'm gonna drag and drop to the here. So first TX to here, export chop, export Y to the Z, and this is all here, Y and Z. And the uniform scale is 0.1. Okay, next is for body. So I'm gonna add the circle, and division is 4, and then I'm gonna add the chop 2. And I'm gonna drag and drop to the chop, and I'm gonna turn on the compute normal, and I'm gonna add the extrude, but it's too much. So depth scale is so you can change it for you. You can change it, but I use the 0.045, and also I'm gonna change the depth translate to center, to get center the body. So I'm gonna add the minus me dot par dot depth scale divided by 2. Okay, so next is I'm gonna use a chop 2, and I'm gonna add to the here, and I'm gonna add the wire plane, but it's too thick, so I'm gonna change the wire radius to 0.025, and I'm gonna copy and paste. And second one is for left arm, third one is for right leg, fourth one is for left leg. Okay, so I'm gonna add the merge, and I'm gonna connect everything. Wee, cool. Okay, and next I'm gonna add the delete. So I'm gonna call it here is a pure data, and then back to the here, I'm gonna add the use number. So if you add the use number, I can delete all of them. So if I don't have the data from here, I want to delete the shape. So I'm gonna write it the code of pure data dot num samples, no, num chance means channel less than equal 0. So, and I'm gonna add the no, and I'm gonna call it body, and I'm gonna add the geometry, and I'm gonna add the font material, and then diffuse 0, and this specular is this one 0.1, and then soft shyness is 1, and I'm gonna add. It's very dark. I can't see. Okay, perfect. So let's rendering. I'm gonna add the camera, and I'm gonna add the no. This is for lookup. So and then I'm gonna drag to the drop here, and the camera translate is 2, 1.3, 1.4, and I'm gonna change the FOV angle from the view, and it would be 86. Also, I'm gonna change the translate of the lookup minus 0.4, minus 0.1, minus 0.9. So basically it's depending on your like video or your video device thing. So you need to change the location of the camera after that. This is my setting. Okay. Also, I'm gonna add the light, and translate is 15. Y is 3.5. Minus 7, minus 23, 57. This is 0. And then I'm gonna go to the shadow, and I'm gonna use the hard, and go to the view. No, go to the light, and dimmer is 4. 0.5 distance light, and go to the view. Use the 100, and far is far. And then I'm gonna add the render. So now you can see the skeleton. So I want to add the like a floor. So I'm gonna add the I usually use the rectangle, and this is for ZX plane. And I'm gonna add the transform, and I'm gonna add the no and the geo, and I'm gonna add the phone material, and diffuse is 1, and then emit is 0.4. The shininess is around here, and I'm gonna apply it. Yep. So this human body don't stand on the like a flat plane. That is like that position is 0. So we need to like adjust the floor for your body. So that's a kind of hustle things. So in my environment, or when I use this video, I already like adjusted. So for me, minus 0.64, minus 2.2, and here is the 12, and the uniform scale is I'm gonna get big. Like here's a little bit rotated, but it collect for me. Yeah, I know it's not the perfect. So I need to change the transform more. But it's okay right now. Okay, so I'm gonna copy and paste it, and then I'm gonna specify only GO1. No, this one GO2, and then render is on for the GO1, and then I want to get the soft shadow, because basically if you get the soft shadow from the right, it's a little bit it's a little bit heavy, so that's why I use the top. It's more like a lightweight. And then I'm gonna add the blue. I'm gonna change to the 0.8. Blue intensity is 0.98. Radius is 0.4. Okay, now I'm gonna add the composite, and I'm gonna use the over and connect to it, and I'm gonna add the transform, and I'm gonna turn on the comp over background color, and the background color is white. And I need to change the alpha as well, and add the no. Okay, cool. Now basically we can get the body with depths. So this is a 3D body. So next one is I'm gonna show you how to add the like effect from the mesh. Effect is like vertical. So I think it's very useful to make there some effect for you, because you can use it for another things, like not the human body, others like a 3D mesh. So we can do it easy in Unreal Engine, because they also always like have a useful features. But in Touch Designer, you need to know how to do it. Like you need to know what's going on behind. So basically, if you want to add the particle from the mesh, you need to add the point with each mesh. But so if you add the particle from the mesh, and then the point is 1, 2, 3, 4, 5, 6, 7, 8. So you can only from the burst the particle from the the corner, but it's not cool, right? So we want to at the we want to burst the particle from the like a random point. So that's the thing. Okay, so what are we gonna do? It's just at the point along this body. So okay, I'm gonna little bit organize this one. From exclude, I'm gonna add the sprinkle. And also, I'm gonna copy and paste the exclude to here, but reconnect it from the circle one. Oh, gosh, from the first input. And then I'm gonna add the here, and I'm gonna add the here. So now you can see we at the point from the like a randomize position play option. Okay, that's cool. So but I don't need the amount of the particle, so because it's gonna be so heavy, so just use the 40, and then I'm gonna insert the marsh and then here. So now if you see the point, yeah, like this, that's cool, right? Okay. Next one is for the arms and the leg. So this is also a little bit tricky. So okay, first I'm gonna add the resample. So I'm gonna turn off the maximum strength, and I'm gonna turn on the maximum segment, and I'm gonna type the 8. And if I see now 2, yes, now I have a 9 point because segment is 8. And then I'm gonna add the circle, and the radius is 0.035, and division is thick. So now I'm gonna use a sweep. Have you ever used that? So this is a second input, the first input here. So now you can see I can duplicate this circle along the arms, and then now little bit organize it. I'm gonna add the poly patch. So now I can make the mesh, but we don't need to use the mesh because the wire is more decent. For me, this is good because a handle is rounded. So I'm gonna to do that, I'm gonna change the output division to 1, and I'm gonna delete, and then I'm gonna add the delete geometry key point. So now we can get only point. Okay, last I'm gonna add the merge and then connect it and reconnect it. I'm gonna organize it. So we can do the same thing for the arms and the legs as well. So this is a good feature. So I'm gonna select all of them, and I'm gonna do a collapse select. And if I copy and paste, and move it, and I'm gonna reconnect it, and I'm gonna reconnect it, connect it, dun. So I'm gonna delete the wires. So yeah, you can see that. So if I click on the display option and point, yeah, like that. So you can produce the particle from this point. That's more average position. It's cool. So this is a really cool thing for the touch designer, because you can modify the point, because if you want to do Unreal Engine, you have to export the model to the Blender or Maya or stuff like that. I don't know, maybe we can do that in the Unreal Engine also, but the touch designer is you can do easily in touch designer. But I know there is a lot of the feature in the SOP. I don't remember all of them. I just remember few. too much. That's too much. It's okay. Okay, so next we're gonna make the particle. So from the full body, I'm gonna add the SOP 2, and then I'm gonna rename it RGB, and I'm gonna add the no. So from the no, I'm gonna add chop to top, and data format is RGB, and the pixel format is 32-bit float, and I'm gonna add the crop, and the crop top is 8, so we can extend the top, and I'm gonna use no, and then I'm gonna add the GLSL. So I'm gonna make the information of the particle in the GLSL. So, and also like I'm gonna use the computer shader, not pixel shader, because computer shader can get the information of the last frame. So which means pixel shader can't store the data of the last frame. Maybe I bring up the example last tutorial. So I don't want to date with pixel shader because she always forgot the memory of the yesterday, but the computer shader always remember. So you want to date with the computer shader, right? So that's why I want to use it. And then in the particle have a like core data. Okay, that is a position, velocity, life, how particle move. So basically, if you change the position, particle move, right? So the position is decided by velocity. The velocity is changed by external force. So that's why we are gonna add the force. Okay, so I'm gonna add the noise. So noise period is 2. So I'm gonna turn off the monochrome and I'm gonna go to the translate and I'm gonna add the abyss time dot second 2 first. So I'm gonna multiply 0.5 and then RGB is just noise and I'm gonna add the math. So I want to like add the force from here, and especially I want to add the the upward y vector force, so we can adjust here. So to R means like the force of the X, so it's a 1 to 1, that's general one, but G is for like Y. So this is a minus is 0.5, but the maximum range is 2. So we can add the more like flying to the space force. And G is a simple 1, 2, and I'm gonna add here. So let's write some code in compute shader. So I'm gonna close this. No, I'm gonna write here, not here. I'm gonna close it. So you should write the code in here. So before do that, I need to add the some. Okay, output access is a read and write, and I'm gonna turn off the clear output, and then buffer is full, and go to the vector. First is u life, land range. What the name is u fps. Third one is u time, and life when the range is 1 to fps is 1 divided by me dot time dot late, and u time is abyss time dot seconds. Okay, perfect. So let's write the code. So I'm gonna click on the edit. So first I can I want to get the vector uniform. So first is a u life land range. Second one is uniform float u ps uniform float u time. So first is a big for color, and the second is a big for position, as I said, equal. So I can get the the image of the last frame. So image load parentheses mtd compute outputs, and the index is 0, and I back to gl global invocation id dot semicolon. Okay, next one is a big for velocity equal image load mtd output 1, and I back 2, and then gl global invocation id dot xy. And last one is back for this is life equal same, and this is for index is 2, and the back for init pose. This is the initial position equal text cell fetch. So which means I can get the image of this one. So std input, and the index is 0, and invocation id and 0. Next is as I said, we need to external force. So this is a noise force equal textile fetch, and then index is 1. Okay, and then other is same. Okay, and velocity. How we can calculate the velocity? So velocity is x, y, z plus equal. As I said, we need to force and x, y, z and multiply u fps stick. So maybe if you learn about the physics, so you're familiar with that, but if you don't, that's a equation of the the relationship between velocity and force. Usually there is a like a weight math, but now I don't include it, but they have a like math as well. So okay, position xy is plus equal velocity dot xy multiply ufp. That's also the calculation of the position, and we need to decrease the life by UFPS tick. So that's a life, always the life is decreasing, and then the life, if the life is 0, the particle reproduce again. So life x minus equal UFPS tick. So I want to randomize the life. So now here is if life dot less than 0.0. So life dot y equal td Perlin noise parenthesis Bexley GL global invocation dot x GL global invocation ID dot y and u time. But we have a u life random range, so I want to remap the the range. Now is I think now is a -1 to 1, so I don't use the minor like a minus negative value. So that's why I want it. So there's some really useful function of the map. So I'm gonna just copy and paste. So this one, the map function, float map, and the argument is a value, and second argument is min 1, max 1, min 2, max. So we can remap the value to the max. So please write it, and I'm gonna use it. So if you like Google the GLSL map function, you can probably you can get their GitHub page, and you can copy and paste it. Okay, I'm gonna use it. So map, and go here, comma, and -1, 1, 2, u land range dot x u land range y. So now I can remap it. So if the particle die, I can initialize the life. So, and I'm gonna store the the life, not current life, the life, the initial life to the life, the second channel. So, and then I need to like initialize the position. So position xyz equal mix init pos dot xyz and the position dot xyz, and I'm gonna use a step. So 0.0 and life dot not the y x. So the current life, if the current life less than 0, so this value is 0. Otherwise it's 1. So I'm gonna use this one. And if it's die, I'm gonna use the initial position. So do the same thing for the velocity. So velocity xy, and then the initialize is 0, and then yeah, the same. Okay, and also we want to do that for the life. For life x equal mix, and then I'm gonna use this. So is a life dot y and life dot x and life dot. Okay, perfect. And also this is my preference. I want to add the scale to life dot alpha is smooth 0.0, 0.3 life x minus here is life dot y minus 0.3 and life dot y, and last one is life dot. This is for scale. And lastly, I'm gonna store the information. First is position, and second one is for velocity. So don't forget to change the index, and the third one is life. Okay, perfect. I hope it works. I'm gonna save it. It didn't work. What's going on? Okay, TD purring noise. Okay, it's type miss. It's type miss. I don't have to use an E. So now, okay, perfect. So just in case, I'm gonna clear output first. Okay, so I'm gonna have the render select 1, 2, 3, and I'm gonna drop here, and I'm gonna select all of them and then drop it. The first one is 0, second one is 1, third one is 2. Okay, so and then I'm gonna have to know, copy and paste. First one is the position, second one is velocity, third one is life. Okay, I'm gonna have the box up, and at the transform, the scale should be small, 0.01, and I'm gonna have to know, and I'm gonna have the geometry. So let's do instancing. I'm gonna have to drag and drop to the position and then type select RGB. Ooh, now you can see that. Oh, cool, that's cool, right? And the scale is life, and I'm gonna add Alfred. So also I want to change the render section, because if I don't have a the data, I don't want to render it. So I'm gonna type here null for this one dot num chance more than 0, and then I want to on and apply it, and diffuse is 0.1 and shyness is. So let's go to the render one, and I'm gonna the GO3 as well. So yeah, now you can get the vertical based on the body. Cool. Okay, that's it. If you like this tutorial, please push the like button and then subscribe my channel. And if you want to get the sample file, check out my Patreon. And also I'm preparing some like event or competition in the Patreon. So if you're interested in, also like check out my Patreon. So I always support every artist, every programmer to use a touch designer and the Unreal Engine. So those who are passionate to make their interactive experience or visual, audio visual, some things like that. So that's why I'm making the tutorial for them. Okay, thanks. See you. Bye. Next tutorial. Bye.